Okay, so absolute value functions have a very definite look to them. Okay, they have this V shape that either opens up or opens down. Okay, so we're going to start. Um, so as we learn, guys, many functions, and this is one of them, they have what's called a parent function. Okay, um, and this is the parent function for every single absolute value function. So let's take a quick look at this. Okay, guys? And it just follows the rules for absolute values. Okay, meaning, remember, it's a distance. How far is a value from 0? So it always results in a positive number. So if we have the parent function y equals absolute value of x, whatever you put in for x comes out positive. And because of that, look at the way the graph looks. Yes. Mm-hmm. Right. And do you see how it makes that V shape? Do you notice that? And so we have a very special point here. It's called the vertex. We're going to talk about these vertex points more and more this semester and next semester. So it's always going to be the lowest or the highest point. Okay, so go ahead and make a nice big chunky dot right there at that lowest point. This is known as the vertex. Okay, and it either opens up like this one or it's going to open down, and we'll look at an example of each. Okay, so the first thing we're going to figure out is how to find this vertex point. And it all has to do with this. It has to do with these two values, h, or negative h, and k. And it goes back to what we learned when we were talking about transformation of functions. The first value, the h value, is either going to move the vertex, that lowest point, right or left. So it controls the x-axis. And the k value, remember what the k value, if we added something to our function or subtracted? The y-intercept, or the y-axis more. It pushes your graph up or down. And it's going to do that here. Okay? So, for example, let's take a look. Got to pick a good color here. All right, let me pick this one. Let's see here. We're going to find the vertex. So the vertex point is always going to be the following. Your x value will be the opposite of h, and that will be x, and your y value will be whatever k is. And that's going to be the lowest or sometimes the highest point on the graph. So let's practice finding this. Okay, so first of all, let's look at this value, our h value. This is going to translate into a value for x. Okay? So if within the absolute value I have plus 2, do you notice it has minus there and here? So you take that positive 2 and you take its opposite. What's the opposite of positive 2? So that means the x value would be negative 2. Okay? Now, for the y value of the vertex, you're going to take the k value. What's the number for k? Is it 3 or negative 3? Negative 3. This one you don't make opposite. You just, whatever number is there. If it's a plus, it's positive. If it's a minus, it's negative. So this tells me the vertex, in this case, the lowest point is going to be negative 2, negative 3. Okay? And that's honestly probably the hardest thing to do here. Figure out that vertex point, because from there you just build the rest of your graph. Okay? So let's find some more. Let's find the vertex for this one. And again, we're going to start with the h value. Our h value is negative 1, but we want the opposite of that. So what number would go here? 1. Okay. I don't have anything for k. So how does that translate to our coordinate? 0. If you're not adding or subtracting anything, that means it's 0 here. So the vertex point would be 1, 0. Any questions there? Okay? Milton, focus. All right. Let's try this one. I'll let you guys decide this one. Take a look. Identify the value for h, identify the value for k. What do you think it is? What's the value for x based on whatever h is? What's the value for k, for y based on whatever k is? Okay, what should I put here? 0. Yeah, I'm not adding or subtracting anything inside the absolute value, right? So that's 0. What's the value that would go here? 4. Okay. Any questions? All right, so that's the first thing. Figure out how many across and how many up or down we're going. So half the battle is done there. Okay? So let's move on. So this is going to be the steps we're going to use to graph. We're going to find the vertex. Done that. Not difficult. Then we're going to make a quick little table. Just like this. And then we're going to represent the function with a vertex in the middle of the row. So here's what I'm going to do. 1, 2, highlight this one. Highlight that. The third row, highlight it, please, if you have a highlighter. Or somehow identify that. You could put a little star there if you want, if you don't have a highlighter. That's going to be important. Now, and then we're going to graph the points. And it's always going to have that typical V shape. So you guys ready? So this is going to be our function that we're going to graph. Y equals the absolute value of x minus 2. Okay? First thing we're going to do is identify the vertex. And that value is going to go here. I'll put a little V there for vertex. So let's figure out, what's my x value? 0. Right? I'm not adding or subtracting anything. H, basically. Yeah. What's my k value that goes there? Negative 2. Okay. So there we go. We got that. Let me go show that a little better. So we want that one in the middle. Now we're going to pick a couple of numbers less than 0, a couple of numbers bigger than 0. Okay, so that's going to be the next thing, and now we're going to use a function. Okay, so I want a couple of numbers less than 0, so -1 and -2 would work there. A couple of numbers bigger than 0, so 1 and 2. And we're going to find some symmetry as we work this out. Okay, so you guys ready? First thing we're going to do, and we'll try to do some mental math. We're going to replace -2 for x. So what's the absolute value of -2? 2. Everyone agree? 2? So 2 take away 2 is 0. So the value here is 0. Okay? Let's try the next one. Absolute value of -1 is, take away 2 is -1. And if we did this correctly, we should get those same numbers repeating down here. Let's see. What's the absolute value of +1? -2 is -1. Same thing here. The absolute value of 2 is 2. And 2 take away 2 is 0. So they repeat. We want that symmetry, actually, guys. If you did this correctly, you should get that. Okay? So now let's graph our points. We want -2, 0, right there. -1, -1, right there. 0, -2, right there. 1, -1, right there. And 2, 0, right here. And let's just extend those points in either direction. And there, we just graphed our first one. Okay? Any questions? So, not too bad, right? That was number 3. Shall we move on to number 4 when you're ready? Let's try it. Okay. So, I honestly should have, I'm going to add the vertex here because I always want to list the vertex. Like, I'll list the vertex here. Okay. Everything okay? Oh. Okay. So let's find the vertex for this one. All right. So let's see here. This is going to, what's the x value going to be? 2 or -2? -2. Remember, take this number, make it opposite, -2. And so what's our y value, the k number basically? 0. Okay, so what we're going to do now is we got a total of 5. Yeah. Maybe the highlight of their life, leave them alone. Okay, so let's put that vertex point here. And we're going to, again, pick a couple of numbers smaller than this. Maybe -3 and -4. A couple of numbers larger than this. -1 and 0. Because we want that symmetry. We want the numbers to be balancing out. Okay? So we got to be a little careful here. So I'm going to do a little side work. Okay? Let me pick a different color. Okay. So Hmm?
So like when we're doing it, instead of like actually doing like x minus 1, do x plus 1.
Yeah, what you want, yeah, when you're calculating it, yeah, you're going to do the opposite. So I'm going to do that first number. So let's say I have negative, and I'll do this -4. Absolute value of -4 plus 2. Let's see what that gives us. So -4 plus 2 is what? -2? But we want the absolute value of it, right? So we want the absolute value of -2. And we got that negative outside. Do you see that? That negative is this one. And we want the absolute value of that. So what number is that going to give me? -2. Because this will make it positive, but the negative outside will make it negative. So this is -2, and this is going to be -2. Okay? These balance out. So let's try again. Let's do this one. And we're going to do the same thing. We want y equals negative absolute value -3 plus 2. So let's see here. -3 plus 2, that's -1. So we want opposite the absolute value of -1. What number is that going to give us? -1. This would give us +1, but that negative outside will make it -1 and -1 there. Okay? So let's try it out. Let's plot the points. -4, -2, so 1, 2, 3, 4, and down 2. 1 there. And then we want -3, -1 right there. -2, 0 right there. -1, -1 right there. 0, -2 right there. This one's different, isn't it? This is called opening down. This opens up, this opens down. Okay. So I'm gonna go ahead and I'm gonna point that out. This one opens up. Opens up. This one opens down. Why do you think, what causes one of these functions to open up or open down? What do you think? Hey, man.
That being outside of the
This maybe?
yeah, I just forgot that.
The negative or the opposite sign?
No.
Yeah. If you notice in our first function, let me bring it down. Do you see our first function? We didn't have a negative out in front. It opens up. Here, this one, we got the negative in front, opens down. So that negative will cause it to open up or down. Okay? Any questions? Let's try some more. So, oh, is anyone still writing this down? Allison, were you done? Okay. Let's move on to number 5 then. Let's get that vertex. Let's take a look here. Where is that vertex point? Look at the H, look at the K. Don't be afraid, you can only be right or wrong. It's a 50-50. What's the x value for the vertex? 3, positive 3. You take the negative 3, you want the opposite. 2. 3, 2. Okay. So I think at this point, shall I show you a shortcut? Okay.
This is gonna be
Yes, that was going to be my next question. Let's see what we already know. This is going to open up. This is positive. So let's take that into account. Opens up. Vertex is 3, 2. And the other missing component we haven't talked about, the slope. The slope. We get the slope from here, remember? The coefficient of x. What's the coefficient for x? 1. That's important. So the slope is 1 over 1. I like the way I heard it. How am I say this? 1 over 1. It is 1, but we want to think of it as a rise over run because we want to graph with that. So with these 3 pieces of information, we can make that line, guys. You ready? Okay, so write those down. Opens up. Got that. Vertex is 3, 2. Got that. Slope is 1 over 1. First thing you're going to do is find that vertex point. 1, 2, 3, up 2. There it is. Okay? Now, is it going to be shaped upwards like this or downwards? Up. So go from here, use the slope to find another point. Up 1 to the right 1. So from here we go up 1 over 1, up 1 over 1. There's some points for this. Here's where it gets tricky though. Remember, this is the vertex. That's the lowest point. If it was opening down, that would be the highest point. So do I want to go down and to the left and make it a regular line? You want to go up and to the
right left.
Up and to the left. Up and to the left. It has to be that mirror shape. We want that symmetry. We have to have that symmetry. So we won't have to make the table if we remember those things. Okay? There it is. Just remember the shape it has to have, that B shape, either opening up or opening down. Okay? So you guys ready for the last one? Here we go. Take a look. How will it open? Up or down? Down. This one opens down for sure. Next is the vertex. All right, so let's get those vertex numbers. What's my H and K numbers that are going to go there? Okay, so 1 here. Okay. And finally, the slope. In case you're wondering, how do you figure out the slope? Look at where x is. Look at x. Is there a number in front of x? So the coefficient is 1, right? So the slope would be 1. So in this case, we would use 1 over 1 again. That's how we get the slope. Okay? So here we go. Let's find 1, 3. 1 over and 3 up. And we want this to open down. Oh, so if we want it to open down, Why don't we make it negative 1 over 1? Remember, we want this to open down, so
Oh, so like we can kind of like count the sign as the absolute value like that.
yeah. So this is going to be the highest point. This is the vertex, that's the highest point. So do I want to continue going in this direction upwards? No, we want to go down in this way because we know the shape it should take. It should do this. This is it for the notes. So it should do this because it has to open down. Any questions? Okay, so hopefully I didn't lose you on the last two examples because it's the quicker way to graph these. Figure out if it opens up or down, determine what the vertex is, and then graph the line with the slope. Yes?
For the Cami, do we have to show our work?
If you figured out this is all the work you have to show. Okay?
Do we have to go up and down?
Yeah.
How do we find out the slope?
The slope?
The
The coefficient. The number in front of x. Go look where the huh?
What if there's a number in front of x?
Say it was 2. Then the slope would be 2. Or as a fraction, 2 over 1. So you would go up 2 over 1, up 2 over 1, or down 2 to the left. Okay? Any other questions? Yes.
How do you decide where the slope is going? Down or up?
Oh, that has to do with opens up or down. So, do you see how this one opens down? So that means over here it has to go down 1 over 1.
I mean, I know what up and down.
Like how do you know?
Oh,
If it has like a negative outside of it, then it comes
okay, let's take a look at the Cami.